All right, so in this video, I'm going to review with you guys how to solve a quadratic equation by factoring and using zero product property. So the problem that I want to start with looks something like 0 equals x squared plus 8x plus 7. And I do want to remind you that when you're solving an equation like this, you might be looking for x-intercepts, right, where your y value is equal to 0. X-intercepts can also be called solutions or roots on a graph, but it's essentially wherever your quadratic or function or whatever it is equal to 0, and so you're finding like x-intercept, root, or solution. Okay, so before we begin, I want to refresh and review these concepts using like a box and diamond method of factoring. And so your first step is always going to look something like setting up a box like this. So this is the box, and the diamond is this guy over here. And there's just a couple of patterns to remember when you're doing this. So remember, your first term always goes into the first box, and last term in the last box. Okay, and then we multiply the diagonal together, and I get 7x squared here. Remember that the whole point of this is that you're trying to find the factors along the outside of the box. This right now is the area of the box, or generic rectangle, as a sum. So if I add up all these pieces, I should get x squared plus 8x plus 7. But what am I multiplying along the outside? What is the area as a product? Okay, so essentially I need the diagonals to multiply to 7x squared, but I need these two boxes to add up to 8. That way when I add all the boxes together, I get the area as a sum, which has got to be an 8x plus 7. All right. Now, this one's a little bit easier because 7 has only one factor, one in itself. But if you're not quite sure, like let's say we've got harder ones to do, then just set up your factors. I could do 1 times 7. Or if it were the number 6, I could do 1 times 6, 2 times 3, and et cetera, et cetera. So you kind of build it yourself that way. All right. 1 and 7 do add up to 8. So I'm looking for numbers that multiply to the top, but they're going to add up to whatever's on the bottom. Well, 1 plus 7 does equal 8. So I'll put a 1x here and a 7x here. Now those two terms match right into the boxes over here. Notice that the order that you put them into the boxes doesn't matter. Okay, but from here, you're now going to want to factor out what they have in common. So what do these two boxes have in common here? An x squared and an x? Well, the term they both share is just 1x. So I factor out 1x along the side. Okay, what's the common term between 7x and 7, or common factor? I apologize. Well, 7 goes into both, so I pull the 7 out along the side there. And then x times x gives me x squared. X times 1 gives me this. And just to check you've done it correctly, 7 times 1 is 7, and so that's correct. All right, that means that this sum can be deconstructed into a product, specifically x plus 7 and x plus 1. Okay, so the other part of this lesson really goes back to this idea of zero product property, which is essentially to say that if I have two numbers being multiplied, and the two numbers in this case are x plus a 7 and x plus a 1, if those two numbers equal 0 when multiplied, then one of them had to be 0. That's just what zero product property tells us, right? So that essentially means that either my x plus 7 term had to be 0, or my x plus 1 term had to be equal to 0. And really quick solving, I can find that x has to be either -7 or -1. And I'm using set notation. This notation with curly braces is appropriate anytime that you have multiple answers for x or multiple values for x, and it could be 2 or more. So now let's take a look at a more complex problem, but I'm still going to solve it using a box and diamond method. All right, so here's the next problem that I want to take a look at, and you can tell right away by looking at it that it's quite different than the last one, but I'm still asking, what are the x-intercepts, what are the roots, what are the solution? X-intercept, root, solution all means the same thing. Essentially, when is my function equal to 0? So looking at this right away, it's quite obvious that it's not equal to 0 right now. And so we have to do a little bit of the legwork ourselves by moving all the terms to one side and leaving 0 on, one side of the equation. Then I can actually solve. Okay, check it out. I have a 2x squared here and a negative x squared here. I personally prefer to keep my highest term positive. So what I mean by highest term is that term with the largest exponent. So an x squared is the highest one that I have in this equation, and I personally like to keep my highest term positive, and it makes my factoring a lot easier. So I'm going to choose to move all of my terms over to this side. That way I keep that x squared term positive. If I were to subtract my 2x over here, I'd wind up getting negative 3x, and I just don't like that. So it's kind of a personal choice. You can do it or not. All right, I'm going to move all of the terms to this other side. So I'm going to add an x squared, subtract an 8x, and subtract a 9. So on this side, of course, by design, everything cancels out, and I'm going to be left with 0 over there. That's important because I can't really solve this equation without having it equal to 0 first. Okay, 2x squared plus 1x squared gives me 3x squareds. 6 and 8 gives me 14, so negative 14x's, and then 4 with a negative 9, those add to give me negative 5. All right, so as I said, I'm going to continue using the box and diamond method to factor. So let's draw ourselves a generic rectangle or box, and the first term always goes into the first box here. The last term goes into the last box here. And then from there, I multiply them together and set up my diamond. So 3 times the negative 5 is negative 15x. And recall that these two boxes, they must add up to the negative 14x that's already in the equation. Okay, so what are the factors of 15 that might add up to 14? Because I'm looking for numbers to multiply up here, but add up to whatever's on the bottom. So let's go through factors of 15. Don't forget that 1 and 15 is an option. So that tends to be one that students overlook pretty often. But I always start with like 1 in itself. Okay, does 2 go into 15? No. How about 3? Okay, well 3 times 5 would give me 15. That makes sense. I already had a 3 and a 5, whatever. 4 doesn't go in. 5 does go in, but by the time I get to 5, I actually start just repeating myself. So these are all the factors of 15. All right, would any of these possibly add up to 14? And remember that, of course, one of them has to be negative because I'm really trying to multiply to a negative 15. So could I pair either one of these with a negative and get them to add up to a negative 14? No, 1 and 15 would work. So if I cause the 15 to be negative and leave the 1 positive, then I am going to have them adding up to a negative 14 value. So those are the factors that I want to use. Okay, again, it does not matter the order that you put your terms into the boxes. I prefer to keep my negative values together, so that's why I put the negative 15 next to my negative 5. That way when I factor out what they both have in common, well, they both have in common a negative. So I can take out the negative 5. Here they only share a factor of x. X times 3x would give me 3x squared, and times 1 would give me that. Just double check, right? Negative 5 times 1 is negative 5, so it's all good. We factor correctly. Okay, so the terms along the side and along the top become my factors. I'm going to kind of move over here so I have a little more room. So this equation factors to 3x plus 1 times x minus 5 equals 0. And essentially, I would just split off into, evaluating when each factor itself is equal to 0. So I have that either 3x plus 1 equals 0 or x minus 5 equals 0. And with a little solving, right, subtract 1, divide by 3. This one here tells me that negative 1/3 is a solution. And then this term over here, if I add the 5, I also find that 5 is a solution. And again, I'm going to use my set notation because I have 2 answers for the value of x, and set notation would be appropriate when reporting 2 or more answers. Okay, so big takeaway here, if you're solving for a quadratic, x-intercepts, roots, or solutions, you have to have it equal to 0 first. So that was that step. Box and diamond is going to work for factoring, and then employ your zero product property in order to find your solutions there at the end.